Well, hi, good morning, and thanks so much for joining me here in my shop. So I think the first thing I want to do with this radio right away is get rid of this guy here, this rectifier. This is the high voltage rectifier. There's not really high voltage in this radio. Probably 160 would be the highest it would get. I don't think it's anywhere near there. So this is a really easy thing to replace. It's just a diode. It's really quite simple, except for the fact it's just like working on the big capacitors. When you remove them from the circuit, some terminals disappear too, and then you've got components with no terminals to go to. Already in this radio, they've used this connection to steady up this, which is kind of floating out here. This is one of the connections that's going to, of course, to the rectifier. The other connections here, and you see the rectifier is bolted onto the chassis, but I'm pretty sure it's not actually connected to the chassis, so let's check that out. Just make sure, just watching the meter. There's one terminal and the other. Yeah, what happened there? So although it looks like it's bolted to the chassis, electrically it's actually insulated away. And if you look close enough, you'll see little insulating wafers in here. We were looking at that on the last video briefly. So in order to maintain this, it's good for me just to leave this connection just like it is. And what I can do is I can just cut this resistor free and just connect the diode down to here, just around here. That'll leave this connection pretty solid. Doesn't matter, I leave it on the post here. This will be going nowhere once I cut this wire off here. So I just need a diode to replace that guy, and can't be too demanding, so I will pick one. Okay, let's take a look here. I'm going to pick one of these 1N4 series diodes. So in this application, these are all 1 amp forward. It's just the reverse voltage that's getting higher and higher. So I think 400 volts is more than enough reverse voltage strength. So I'll pick this one, a 1N4004. Good. Okay, here's my 1N4004 diodes. Okay, and just going to put it in there. Soldering attempt number, actually installation attempt number 3 on here. Really close to the capacitor now. Be quick. Quick, quick, quick. Okay, once again, how's that look in the camera? Looks okay. Okay, ready to try again? Does Jim know left from right? Apparently not. Once again, this goes on the positive end of the terminal here. Negatives going on the negative terminal. B minus spot. Put away the solder before we have an accident. Okay, I think everything's set here. Yeah. Power on. It's a positive number. Fantastic. 150, that's pretty good. That's pretty good B+ for a radio like this. pull down to pretty low. So we still hear that same hum, which I secretly had hoped would disappear when we took this out of the circuit, but that didn't do it. So I think I noticed before the hum, let me take this off now, the hum is not sensitive to the volume control. So that suggests it's coming in after the volume control. Let's just go ahead and do a little signal tracing here and see if we can track it down. Very interested in this kind of hum. So put this on B-, not on the chassis. Okay. Turn down this radio. Oh. It is turned down. Now, so I can't reduce the volume on this radio, so when this guy comes on, I'm going to have to turn it up high enough to kind of overwhelm the sound from here so we can tell the difference. It's probably easier than it sounds. So I'll pick off the signal that's arriving at the volume control. Oh my gosh. So they have to feed the audio signal all the way up to the switch on the back of the radio here. So I've got some shielded wires going all the way up there. Any of that could be picking up the hum. Okay, so we'll go right here. Now I've got to turn up the signal tracer. Well, that sounds like a radio to me. It doesn't sound like I heard any hum. So we'll go. So that's a good indication that there's that sound, that hummy sound, is not there in the radio output, but it's in the audio. So the next thing we could try is to get on the. I guess these two tubes, they can't be in push-pull. They must be in parallel, the two output tubes. And I haven't yet studied enough in here to know what's what yet. So I got this in my hand and I'm really tempted to poke something with it. What to poke? So this is the detector tube here. The audio will be coming out of it. I can't be sure. There's too many wires in here. I'm looking at the different wires coming off this tube, heading to the there's an interesting spot. Okay, that's not working out at all. So 12 SQ7, wasn't it? 12 SQ7. So the audio should be able to hear it on pins 3 or 4, and from there, pins 3 and 4. Pins 3 and 4. There we are. 1, 2, 3. Pin 3. I think it's this one. And you can hear the hum now. So that was pin 3, so that's the detector tube. So the detector itself appears to have this hum in it. This means we would find it everywhere else. If we listen, so I can listen to the IF at its frequency. If there's a hum incorporated in it, I'm not sure we would hear it. Well, why don't we try that? We'll switch the signal tracer to RF, and we want to be on the frequency of the IF, which is 455, I'm guessing. So we want to put this now on the output of the IF, which would be the same as the input to the diodes. The same place I had it before. 2, 3. Now that point, the RF should be, well, there's probably capacitors quieting it down. Let's just see what happens here. So pretty strong hum in my signal tracer. Audible when it's listening to RF. So something going on right with this part of the circuit. So I pull that, oh, I can't do that in this radio. So pull that tube out and see what happens. Yeah, it'll get quiet all right. So the hum is right around the detector. You know, it's probably time to go through the schematic at this point. So maybe a little bit of a rush today. Maybe I'm going to make this a short video. We just did the diode, and we'll save the rest for tomorrow. Well, thanks for watching. So what might help at this point is to spend some time looking at the schematic for this radio. So let's whip through it. First of all, what's going on with these two output tubes here? Well, they certainly look to be in push-pull arrangement. So somehow there's a signal inversion occurring between these two tubes. Must be the job of the 12 SJ7, because you really only need the SQ7 to produce the audio. It would come out here, and then you could send that straight to the output tubes, but if you need an inversion, it must be done with this tube here. So we look back grid this way. So on this schematic, I should have mentioned this right off the bat, what they've done is they've heavied up the lines that carry the important signal. So if we just go back to the antenna, it's hard to see, but in fact all of these lines here are heavied up a little bit. It's all just a little heavier than the rest. Can you see? So you can kind of follow the signal right through here, just following these heavy lines. Coming out 8 through the transformer up into the diodes, and I wanted to spot that. So 4 and 5, the two diodes are just connected together. From this point you would find the signal down here. Here it is. This would just be audio now, maybe a little bit of RF in it. Shouldn't be any though, ideally. Come over here to the phono switch, which amounts to the phono plug. If you push a phono plug into the socket on the back, you operate this switch. Comes through, the audio's coming through, goes up to the triode, out of the triode. Look, only 58 volts on this triode. And then into this tube to produce an inverted signal, a non-inverted one, well, one of the two going here and the other inverted one going here, or the other way around, and then out through the output transformer. 106 volts. We're a little above that now, probably because I replaced this guy, but I don't think there's any harm in that. A couple of volts extra. Here's the light bulb, basically from one side of the line to the other right here. Okay, there's the tubes. The order in which these heaters are connected is significant in the design of the radio, and I couldn't say much more than that. Now, we're looking for a hum developing in here. And I heard the hum on the plates of this tube. the diode right here, right on this pin. I could hear the hum. The hum is either being initiated right here somehow, or it's initiated earlier in the radio and is somehow coming through. You know, from here forward it's audio, but from here backwards it's RF. The hum sounds a little like power supply hum. Well, why would I assume it's not the power supply hum? I'm assuming that because there's great big new capacitors down here. What size are these guys? E50, E20. So I think they mean electrolytic 50 microfarads and 20. And the capacitors that are in is a 40 and a 30 instead of a 50 and a 20. So typically in a radio like this you have a better filtered output right here. Yeah, I like that. It's going to the output tubes. Okay, and the less filtered is going, oh, I'll take that back. No. This filtered is going to the plates. Know what they're going to? It's going to the screen here. Is that a screen? What kind of tubes are these? Screen. Okay, and the less filtered is going to the output transformer and the plates. Okay, that's normal. And this better filtered B plus is then extending back through the radio, getting all the plates of these tubes. Well, we can listen to the plate circuit on any one of these tubes. We can listen to all kinds of stuff here. Try to track down where the hum is introduced. If this is a general sort of thing, it could be all over the place. Tracking down these hums is not as easy as it might seem. Too bad we just can't pull the tube out. You know, I could pull it out and the radio will continue to operate briefly while the heaters cool off. But unfortunately, well, would that really tell me anything? If I just yank this tube out while the radio's operating. So what would happen? So two things would happen. Two things we're interested in. One is the hum would remain just as it is. That would tell us something. And then the other is the hum would fade away. If it faded away, then it means it needs this tube to make it to these guys. So it kind of means it's either in this tube or ahead of this tube. 12SJ7. I tested all these tubes. Tested it on a good tester that can detect small interelectrode leaks. There were none. I should test it again, maybe. Is there anything unusual going on in this radio? I don't think there's anything unusual at all. Here's the local oscillator circuits. Okay, so they're using grid number 1 on the oscillator and grid number 3 for the incoming signal. Is this untunable transformer here from the antenna, capacitor sitting here. So the front end is tuned between this variable capacitor and this coil, or the whole transformer, perhaps you could look at it that way. So a little bit of tuning here, and then in it comes. In some cases, this coil is the antenna. They don't do the transformer. Just out with a coil, out with a loop antenna, coil of wire antenna. Okay, nothing else is popping out here. The next step, I think, would be to listen right on here. Hear what we hear right in the power supply. Yeah, I think that would be the next step. Okay, so we want to listen. listen right on. Okay, I'll power this guy on. Turn on our tracer. Grab my coffee. We're going to listen to the power supply. We're going to listen to it with audio. And again, you can't turn down the hum. Hum is past the volume. Wait a minute, that's kind of counter to... That's kind of counter to some of the other tests I did. Yeah. Okay, power supply, positive, right here. It's going to be a bit of a pop. No. Oh, listen to that. Oh my gosh. What's going on here? And this one. What am I doing here? So this is ground. That's just basically this wire I'm testing across. So this is the output of the diode right here. Whoops. Wow. Okay, other side of the big resistor that comes from this terminal goes onto this tube here. Almost no hum. I got my tracer way up volume wise. So this So this is the incoming power supply here, incoming 120, through a resistor, no filter capacitor here, there's nothing's happened yet, through the diode. So what's this guy for? I remember seeing that on the schematic, right off the power wire. Probably just missed it, but let's just take a quick look. So we're saying the power, yeah, right here. Here it is, right here. 22 ohms. Oh no, that's in the heater strength. That's not it. It'll be the 100. It's going to be this one here. 100. 1 ohm, 100 watts. So, yeah, brown, black, brown. 100 ohms. So that's what I'm seeing right here. That's fine. But here there's a pretty strong hum. But here there isn't. Here there sure is. And this is going straight out. So is that capacitor no good? Why so hummy right here? So it's supposed to be a 50, and there's a 40 in there. I could boost this capacitor, and we'll see if that hum goes away. I mean, that's the thing to do. Let's do that. Okay, so I need a temporary boosting capacitor here. And I have one. 250 volts, 100 microfarads. Wow, this will really do the trick. I think I want to charge it up through a resistor, a smallish resistor. So, positive in there, negative in there. We want to charge this guy up. Negative. Let's try it quickly here. Whoops. We're on the negative end of things. They come down here. Negative end. I just don't want to, just a big capacitor. Yeah, how am I going to do that safely? So what we're going to do, we're going to shut it off and then clip it in and turn it back on. A big 100. Negative, positive. Okay, hopefully we don't blow this little well, that's what this resistor is doing. This resistor is keeping that guy from getting blown by these big capacitors. Hope it's enough. There we go. Stand back, everybody. Okay. Sound any different? Now remove it and we'll find out. Careful, man, don't fall over. No difference. Ah, there it is. I've been looking at this connection for a long time and I have not seen a wire connection that's there. That's the wire that goes to the center tap of the output transformer. Humming like crazy and not sensitive to the volume. Still on audio. It's just, it could maybe the hum is introduced close to the output tubes, but it's going everywhere. And as any one of you is saying, well, just change all those paper capacitors and the hum will go away. You know, it could be the truth. So on the output of the volume control, but it's turned down right now, the input to the volume control. I don't hear the hum there. This is on the output of the volume control here. Oh. Output of the volume control. Yeah, this guy has his own hum. Right. Okay, follow the signal further along from the volume control. So this is the other side of the blocking capacitor coming off the volume control slider. Well, that gives me the impression, hey, come on, Jim. This thing has a phono switch. Switch the phono switch. Is that it? Feels like it only went halfway. Hum definitely there. Volume having no effect. So I've cut off the radio from the amplifier. Clearly it's the amplifier. The amplifier can produce this hum without the aid of the radio. So on the 35L6 tubes, 35L6. So the grid is pin number 5. Pin number 5. Okay, 1, 2, 3, 4, 5. So the other side of this capacitor here. So when I touch this, you don't hear anything from the radio itself. Everything you hear is coming from the... So I think I can hear a hum in the tracer there. I mean, it's coming out the speaker. It's got to be on the grid of that too, doesn't it? So we come back further. You could look at the input to the inverter tube. That'd be the 6J. You know what? I've been doing this wrong. This is the 6SQ. This is the 6J here. So when I thought I was listening to the plates on the 6SQ7, I was not. 12SQ7. 12SQ7. 3 and 4. 3 and 4. Yeah, because I noticed before that 3 and 4 were not tied together on that tube. So that should have been the hint right there. I was on the wrong tube. So here we are. Audio output of the detector at the diodes. So I don't think there's any hum there. So it looks like no hum output of the detectors, no hum at the start of the volume control. The other side of the volume control appears to be humming. That's kind of weird. Let's look at that again. So here's input. Input to the, sorry, I just got totally distracted there for a moment. Lost track. Okay, diode plates again. There's nothing there. Input to the volume control. That's what I wanted to do. Oops. I jumped because I got a little nervy thing in my thumb there. If you do this kind of work all the time, you know what I'm talking about. You get little nervy pinches and things that happen, and they feel a little like electric shock. And so I'm on audio here. What happened? There's no. Oh, I'm on phono. I'm on phono. That's why I can't hear the radio. Okay. So again, that's a valid test then. If there's no hum there, let's try it again. No hum, no sound. It's just the signal tracer's own hum. No hum there. But on the output, no, I wouldn't say there's a hum there. Okay, let's keep going then. Keep following along, just what we were doing before. So now we come down to here. Now, that's interesting. So we're hearing only the radio right now. The signal tracer is turned right down. Where's the hum? There's the hum. Why isn't it there when I do this? And the radio starts sounding quite normal. Maybe this capacitor? Other side. And this side. So that's a pretty sensitive grid connection there, I'm pretty sure. And when I hit the other side of this capacitor, you don't hear it at all. Maybe it's just because the volume is shorting it out here. Okay, because I'm on phono, there's no output. Let's try that again. Would kind of think this would sound the same at either end of this capacitor. Is that what would cause this kind of hum? You know, it sounds like, I think I said this right off the start, it sounds like a high impedance input to a grid. So if this capacitor is open circuit, then that's what this would be. It would just be basically an open circuit to that grid, and when I touched it with my probe, I'm actually reducing the impedance of that circuit point from, you know, 1 billion ohms, because it's basically open circuit. So I think that's it. I think this is the problem. I think if we change this capacitor, the whole world will change. Let's try it. I'm going to try it. So I took a little bit of time and went through some of my capacitors and marked the outside foil end with a little dot. Put a little dot on it there. I did this simply with my scope on either ends and just squeezing it with my fingers to inject a bit of signal, and then just flipping the scope around to figure out which one is more sensitive. The interesting thing is the bigger capacitors seem to be less sensitive to this outside foil thing, which I would think is the other way around, wouldn't it be? The bigger the capacitor, but it seemed to be the other way around. Anyway, that's what I've done for what it's worth. So this one was in with the outside foil up this way. I'll do the same. Everybody's off, switches are off. Okay, so I'm going to put this capacitor, I'll put this capacitor in. So I'm sure it's not readily apparent at the start of the video where I'm working on the diode that I put it in 3 times. I think I muttered something about it. Unfortunately, one of my camera shots was all wrong. Well, maybe it's not unfortunate, maybe it's a good thing. Or you would have watched me put that diode in, convince myself it's in backwards, take it out, put another one in the other way around, discover that's backwards, take it out, and correct it. I was right in the first case. Oh, I didn't do the other end of that. So it seems to me, did I solder that? I can't remember. No, I don't think I did. It seems to me, from my experience, about half the time I get diodes in backwards. Try as I may. So I always hook up a meter right away and check. It's always something stupid too that gets me to get it backwards. And in this case, it was not connecting the voltmeter correctly and thinking I'm seeing a negative voltage where there should be a positive. That's all bogus, bogus, bogus. So that's what happened back there. So now we have this capacitor in. Let's get rid of this excess piece of wire which is grounding right out here. Okay, just a little tidbit down here too. Okay. Good. Now, what are the chances that this has solved the hum? Well, it's interesting. If the problem is this capacitor was leading to a very high impedance situation on the grid of this next tube down here, that high impedance would act like a sensitive antenna. And you know, what is there to pick up? Lots of hum. Lots of hum. Okay, get rid of this. Leave my tracer connected. That's okay. This is off. Everything's off. We're good to go again. Radio, what will you do this time? Just want to pull it out just a little bit further. There. Okay. Introducing hum-free radio. Wow. Did it come on? Hey, okay, let's flip the back to radio here. Okay. Hum-free. One capacitor. Thumbs up on that one. That's great. Okay. That's it for this radio today. Thanks so much for watching, and tomorrow we'll do some alignment. I don't think I'm going to replace all those capacitors unless there's some indicated reason for doing it. Oh, well, we'll test this capacitor too, but it's quite clear it was a problem. But we'll give it a test right now. Come on, man, don't give up. Keep the wheels a turning. Let's get it done. Let's get it done. Get it done here. That's my soldering iron that does that annoying beep. Okay, so the objective is to put some voltage on this capacitor, a little bit at first and then more as we go, and then watch this eye. When current flows into the capacitor, the eye closes. Once the capacitor is charged, which should happen almost like that, this eye should pop open. If the current is still flowing in the capacitor because it's leaky, this eye will stay closed or partially closed. Are we ready? We are ready. 50 volts. Can it do it? Looks like a normal capacitor. 100 and so, oh, now the eye is not opening at 150 volts. It's not quite what I was expecting though. I was expecting this thing to show up as if the leads were broken or open on it. But it's showing up leaky. And not terribly leaky either. Well, I don't know, you know. That's why I do these tests, so that I have to stare reality in the face. And what an ugly face reality has sometimes. So that's that. Okay, same thing. Next thing we'll do is alignment on this radio, and we'll go from there. Thanks for watching.